Welcome. Let's take a look at some Venn diagrams. Number 1, a college food court surveyed a group of students to see how many drink coffee and how many drink tea. And our Venn diagram shows those results. And we're going to start with how many students were surveyed. All right, so I'm just going to draw some dots here to represent my people. So in this part of the Venn diagram, I have 5 students, 1, 2, 3, 4, 5. And then I have 3 students there, 4 students there, and then 1 student there. All right, so in total, I would have 5 students plus 3 plus 4 plus 1. So I'm going to call that N here on top of the Venn diagram. So 5 plus 3 plus 4 plus 1. That's going to give me 13 students in total that were surveyed. And then B, how many of those students drink coffee? So inside my coffee circle, 5 plus 3, I've got 8 total students, just writing it there as well. But that came from adding up all the people in the coffee circle. So those are my coffee drinkers. And then how many drink tea? So everybody in the tea circle would be 3 plus 4. So a total of 7. 3 plus 4, 7 tea drinkers in this study. How many students drink both coffee and tea? So those would be those 3 students that are part of both groups. So intersection is our and, so 3. And then how many students drink coffee or tea? So or is union. So we're going to combine the groups. We'll take all our coffee drinkers along with all of our tea drinkers. And we'll talk about 2 ways we could do that. So let's talk about just adding up the students that are in the coffee circle along with the tea circle. So in total, I've got 5 plus 3 plus 4. So that is one way we could get that answer. 5 plus 3 plus 4. That will give me 12 students. So there are 12 students that are inside the circles. So we combine the events. So that's union or or. All right, there's another method that we can use that will be showing up later, and we'll take a look at that now. So let's take a look at it this way. How many drink coffee or tea? So let's take all our coffee drinkers. So if we took all our coffee drinkers, there would be 8, along with plus all of our tea drinkers. And if we did the total tea drinkers, that would be 7. But 8 plus 7, that would be 15, which is not the answer. The answer is 12. So what's happening there is when we take the 8, it includes the 3 people. The 7 also includes the 3 people. So the 3 is getting counted twice. 1 is part of each of those separate events. So we can do it this way. We can take all the coffee drinkers plus all the tea drinkers. We just have to remember to subtract the people in the intersection that were counted twice. We call it no double counting. So we can't count these 3 people twice. So we subtract the 3 and that gives us 12. All right, so either method is fine. Union is the combining of the sets. All right, let's take a look at the next one. Number 2, we have a deck of cards numbered 1 through 8. Some of them are gray, some of them are white. Event A will be that the card is gray, 1, 4, 6, 8. Event B will be the card is even numbered. So that would be 2, 4, 6, or 8. And we're going to start with our sample space. You'll also hear it referred to as the universe. So on Alex, you might see it labeled U for universe. So we're just going to list everything that is possible if we were to pick a card from the deck. So we could either get card 1, 2, 3, 4, 5, 6, 7, or 8. And I'm going to be leaving off the braces, what I call the curly brackets, the braces. So that's the set notation, but you can just list these outcomes separated by commas there. So the universe, we have to get all of those possible values in our Venn diagram. And what we do with Venn diagrams is always start with looking at the intersection. So we're going to do that here, but let me just start building the Venn diagram. So if I look at these two events and what they share, what they have in common, so they both have a 4, they both have a 6, they both have an 8. So 4, 6, and 8 would be part of event A and also be part of event B. So those are common to both of the events. So I'll write those over here. So 4, 6, and 8. All right, so that's the intersection symbol. And then union is the combining of the sets. So I'm just going to do a reminder here. Intersection is and, union is or. So we're just going to put both sets together, but I'm going to finish my Venn diagram first. So let's finish event A. So inside of event A, we've already got the 4, 6, and the 8. So we're still missing the 1. So 1 would be there. And then for event B, we've got the 4, the 6, and the 8, but we still need a 2. So 2 would be there. And our universe, we need all of those values. So I have 1, 2. I don't have 3 yet. So 3. I'm going to cross out. We had the 1 and the 2. I had to put down the 3. We already had the 4. I don't have the 5 yet. We had the 6. We don't have the 7 yet, but we did have the 8. All right, so I think I have them all. 1, 2, 3, 4, 5, 6, 7, 8. All right, so or is combine everything in A along with everything in B. And it doesn't matter if you write them in numerical order. I'm just going to write everything in A. So 1, 4, 6, 8 along with everything in B. So we already have the 4, 6, 8. We just need that 2. So you don't write things twice. These are individual cards. And those would be the cards that were part of either event A or B, or possibly both. All right, and then event A complement. So A with the bar over it is read not A, or the complement of A. So everything not in event A. So everything other than 1, 4, 6, 8. And now that I have the Venn diagram, I can see that easily. So 1, 4, 6, 8 are inside of A. So outside of A, not in A, would be 2, 3, 5, 7. All right, so there's your and, common to both, or combine the sets and then complement not in that event. All right, one more. So for this one, they give me the universe, 1, 2, 3, 4, 5, 6, 7, and then I've got 2 events, A and B. So we always start with looking at intersection. So in this case, they both share a 2 and they both share a 3. So here, all of event B is actually part of event A. So that can happen. And when it does, the Venn diagram will look like this. So all of event B is inside of A. So that circle is our event B. It is contained in, it's a subset of event A. So B is a subset of A. All right, so B is 2, 3. So 2, 3, they are in B, in circle B, which is in circle A. And then to finish the A circle, I still need 1, 4, 6. So 1, 4, 6. And then to finish the universe, so I have 1, 2, 3, 4. I don't have 5 yet, so I'll need 5. I've got 6, but I don't have 7 yet. So then we have our entire universe. All right, so event A intersect B. So what do they have in common? So they share the 2 and the 3. And then union is or, so the combining of the set, so everything in B along with everything in A. So that would be 1, 2, 3, 4, 6. And then event B complement. So the B with the bar over it again is the complement, read not in B, complement of B. So everything that's not 2, 3. So that would be 1, 4, 6, 5, 7. All right. So there are some examples. So just be careful when you read the questions. Sometimes it asks how many outcomes, and then we're counting outcomes. And other times we're asked to list the outcomes, and that's what we're doing in those.